We have seen that the duty cycle of 100% is guaranteed even at the maximum permitted ambient temperature. The actuators are well suited for highly dynamic control loops such as pressure reduction stations, and high-pressure control loops like spray water control valves, or actuators which must guarantee high levels of availability and accuracy, such as induced air fans and suction draft control. Unlike most electrical actuators, pneumatic modulating and linear actuators always have a duty cycle of 100%, so they are suitable for use in highly dynamic control applications requiring a 100% duty cycle. The advantages of pneumatic actuators are their highly dynamic behavior in set value changes and their suitability for applications with safety-oriented fail-freeze and fail-safe requirements. Let's summarize the different operating modes. First, we saw the open-loop control without control loop, as it's mainly used for shut-off valves, such as a turbine bypass. The operating mode here is usually the S2 15 minutes in compliance with IEC 600341. A worm gear is normally selected as design feature of the actuators for open-loop control, which creates a multi-turn power takeoff unit. Auxiliary gear units are mounted on these actuators, which convert the rotary movement into a linear or pivoting movement. This is the simplest constructional design for a maximum of 5,000 to 7,000 operating cycles. In compliance with IEC 600341, the operating modes S4, S5, 25% ED are normally used in intermittent operation. They are modulating actuators for control loops with low demands. Their design resembles to a great extent the control actuators. Normally, these actuators are designed for a maximum of 5 million operations. In compliance with IEC 600341, the closed-loop control S9 100% ED is suitable for continuous control, that is, continuous operation without cooling times. It is used for control loops with the highest demands on the control accuracy and the shortest positioning times. It was designed with spur wheel gear units and for linear actuators with ball screw. The duty circles in the norm refer to an ambient temperature of 20 degrees Celsius or 68 degrees Fahrenheit. In all actuators, the permitted duty cycle is reduced with increased ambient temperature. Only contract actuators with the S9 operating mode 100% need no derating. Even at maximum ambient temperatures, these actuators are 100% available. As we have already learnt, only actuators with the S9 operating mode are 100% suitable for control loops with high and the highest demands. We already know about derating. That is the reduction of the duty cycle at higher ambient temperatures. If the ambient temperature increases, the permitted duty cycle is reduced. The cooling time describes how long an actuator must cool off after operation. The typical efficiency is the relationship of power introduced to power supplied. Ideally, the efficiency would be 100%. The total efficiency is the product of the individual efficiencies. In electrical actuators, this is, for example, the efficiency of the actuator multiplied by the efficiency of the auxiliary gear unit. The efficiency is affected to a great extent by the friction inside the gearing and the mounting. For example, with a total efficiency of 16%, 84% of the introduced power in the gear unit is lost through friction in the form of wear and tear and heat. It is immediately clear that such a gear unit construction is not suitable for continuous operation. The accuracy depends to a great extent on the deadband. This is the area around the set value, in which set value changes are ignored by the actuator and do not trigger motor control. The bigger the deadband, the less sensitive the actuator and the more inaccurate the control. In microprocessor controlled actuators of the S4 and S5 operating modes, the actuator usually increases its deadband automatically as soon as the permitted load is exceeded within 1 hour, or if the duty cycle has been overrun. The accuracy of the actuator is reduced as a result. The maximum dead zone is usually plus/minus 5%. The fields of application for this operating mode are the usual ones. Shut-off valves, for example, are valves which are normally either fully open or fully closed and which are very rarely activated, sometimes only for start-up and closing down operations. Simple control loops are control applications for low demands, for example, slow temperature control circuits. Control applications with high and very high demands are, for example, pressure reduction stations, spray water control valves, fan speed control, etc. What have we learned so far? Open loop control is an open circuit without feedback of a process variable. Closed loop control is a closed circuit with continuous set point actual value comparison. The operating modes S2 to S9 with the corresponding operating times and advantages. So far, so good? Please click on No to repeat the chapter or Yes to continue.